Hi, and welcome to Lesson 1 of the MHF 4U7 IB Math course. We're going to be starting with Chapter 20, and we're going to be looking at descriptive statistics, which you can see there. This is a shot of your textbook, and we're going to be going through this either one section at a time or maybe two sections at a time, depending on how long the sections are. So the idea of this is I'm going to ask you to follow along this video. It'll be 10 minutes, maybe 5 minutes sometimes, 15 some other times. And I'm going to give you the nuts and the bolts and all the main foundation of the lesson in the video. And then the next day in class you have a chance to ask questions. And then we'll move on to some examples, and then you get a chance to practice your skills in class the next day. So today we're going to be looking at 20A, which is the key statistical concepts. Before we get started, what I'd like you to do is I'd like you to go over to page 500 and read through the opening problem regarding a farmer and his organic fertilizer for his crop of peas. And just go through that and take a look at the bottom. There's a few questions that are being asked, and these are the questions that by the end of this chapter you'll be able to answer those questions. And now we're going to take a look at the content of 20A, key statistical concepts. All the stuff that I'm going to be showing you is in your textbook. So you can follow along the video. There will be a little multiple choice quiz along the way as we go, and also the content, of course, is also in your textbook for your reference at a later point. Okay, so let's start going through what these key statistical concepts are. So on page 500 through 502, they're written out all the statistical concepts in your textbook. And I'll just kind of briefly go through these right now. So the population, anytime you see the word population, that's referring to the entire collection of some individuals, some sort of thing that we're trying to find information on, whether it's individual people or animals or types of trees or whatever it may be. Whatever the whole population is, the entire group, that's called the population. A census is the collection of information from the whole population. Now, a lot of times it's not realistic to do a complete census because whether you have a shortage of time or resources or funding or whatever it may be, a lot of times it's more practical to do a sample. And a sample is a subset of the whole population. So what we would do is randomly, and that's the most important thing, randomly choose certain individuals of the whole population and then use that sample, that smaller group, the subset, in order to find information on and then draw predictions about the whole population from that sample. A survey is a collection of the information from a sample. So anytime you want to collect the information, you're actually doing a survey. The data is the information that you collect in the survey. Data is plural, and datum or datum is the singular form. Parameter is the numerical quantity measuring some aspect of the population. So anything you're trying to measure or find information on, that's the parameter. And then the statistic, the quantity calculated from the data gathered from a sample. Okay, it's usually used to estimate a population parameter. Okay, so whatever we're trying to understand about the population, we then discover statistics, or we come up with statistics that will tell us about the parameter, which is measuring some aspect of the population. And categorical variable is some sort of a quality, not a quantity, which is numerical, a quality or a characteristic that we divide into categories. So if you want to find, for example, the people who like different colors, the colors would be the categories. Or if you're looking for the, I don't know, the months of when people were born, for example, the months of the year would be the category. Okay, so just some sort of thing like that, where it's not a number, it's just some sort of qualitative category. Okay, so quantitative or numerical variables, they describe characteristics that have some sort of numerical value that is either counted or measured. And if it's counted, it's considered discrete, and if it's measured, it's considered continuous. So discrete variables have exact values. So we're talking about maybe your score on a test out of the total, 38 out of 40, for example. That's a discrete amount because it's a whole number amount. If you're talking about the number of cars washed at a charity car wash, or the number of pencils somebody may have, those are discrete values. You either have a pencil or you don't. It's not, I mean, I know pencils can get shortened down to have a half pencil, but we'll just talk about the physical item itself. Money is an interesting one. You can have a number of coins. Suppose the number of coins totals 50 cents. Suppose you have 5 dimes. The 5 dimes are a discrete value, the number of coins, whereas the 50 cents part, the actual value of the money, is considered continuous because the money is continual from 1 cent to 2 cents to 3 cents, all the way up, and then it can get into the tens of dollars, the hundreds of dollars, the thousands of dollars, the millions of dollars, etc. So that's considered continuous, just like time is continuous. We go from seconds, and then they add up to minutes, they add up to hours, etc., etc. Or measuring somebody's height or some distance, that kind of thing is all considered continuous. Okay, so we'll take a look at some of those examples, and then we're going to take a look at this example of classifying variables as categorical, quantitative, discrete, or quantitative, continuous. When you have your data and you develop some sort of pattern and you want to graph it, sometimes there are different distributions. Well, there are actually always different distributions. There are symmetrical distributions where everything is beautifully lined up right through the center. Sometimes there is a negatively skewed distribution, meaning that the left edge of it is being stretched to the left, meaning that more of the data is towards the right. That's actually called negatively or left skewed data. And if the right side is stretched, if that's being pulled, then it's right skewed or positively skewed data or distribution. There are, of course, then outliers, and outliers are data that are either much larger or much smaller than the general body of data, and it's still included unless it's the result of human error or some other sort of error. If there's no collection of the data, then even though it's an outlier, it'll still be included in the statistical compilation of data and the analysis of the data. So here there's an example where the majority of the data here is in this frequency table, or there's sort of this column graph, and then the outlier is way up here, and that kind of makes sense because it's 4 above the maximum of this general group, and 7 values above what would be the actual median of the group there. Frequency tables are a great way to organize your data. when you collect data, sometimes you get it in on, it doesn't come all in all at the same time, or you've got a huge group of data that you need to account for. So you can start by setting up columns in a table, and the headings would be tally, frequency, and relative frequency. The tally is used just to count the number of occurrences, so then you see, okay, well, we've got, say, from this example of numbers of peas in a pod, we could say, okay, well, there's 5 peas in this one pod, so you put a tally mark under 5, and then the next one might be 7, so you put a tally mark under 7, and the next one might be 5 again, you put a tally mark under 5 again. So you add it all up, and then the frequency is the summary of the tally, and then the relative frequency is the frequency as a percentage, and of the percentage of the total amount of data altogether. And then class intervals, those are good when you're grouping a set of data in continuous variables, and you want to, suppose you've got a whole bunch of masses of something, so suppose masses of bags of coffee or something, and they're not all going to be perfectly the same amount. Some will be, half a gram above or a gram below or whatever. So if there's a variable of, or a variety of masses to the bags of coffee, you would set them into class intervals, say from one side to the other. So suppose you're saying from 450 grams to 451 grams, and then the next one would be 51.1 up to 452, and then the next class interval might be from 452 up to 453, or something along that line. So you have ranges of data for these class intervals. Now we're going to look at displaying the numerical data, and that comes sort of on the heels of the distribution, which I showed you earlier. Tables are used to organize the data, and then the graphs are used to display the data in more of a meaningful way. So column graphs are used for categorical or qualitative data. So notice in this example, these are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. If you were to say, when were students born? Well, let's say 4 students were born on Monday, 7 students were born on Tuesday, 6 students were born on Wednesday, etc. Because Monday is distinct or different from Tuesday, they are separated by a bit of space. Same thing, Tuesday and Wednesday are completely different, Wednesday and Thursday completely different. So they have a space between them, just like if you're talking about favorite flavors of ice cream. We could have the flavors down at the bottom, and then all of these bars would be separated because there's no continuity from one flavor to the next, for example. So it is, column graphs are used for discrete data. The frequency of occurrence is along the vertical axis, and the range of scores along the horizontal axis, the scores being in this case the days of the week, or in my other example, the flavors of ice cream. The column widths are equal, so that's the same width as that, and that's the same width as that, etc. And the heights represent the frequency. So we can just go across to the frequency axis, in this case the vertical axis, to see what the height represents in terms of frequency of responses. In a histogram, they're sometimes called frequency histograms, other times just histograms. That's for continuous data. So here in this case we're talking about the height of students, and so students aren't all the same height, and so maybe we say, okay, well, we're going to start from 130 and go up to 135, and then 135 to 140, and 140 to 145, etc. So any students that are in this range would be counted, and then any students in this range would be counted. And because it's continuous data, there's no space between them, and the bottom is just the numerical values, the ranges of values, sorted from lowest to highest, from left to right. And then we can just set up how many how high the bars should be according to the frequency, the number of responses at different heights. Okay, so each bar represents a range of data. They're used for continuous data. The frequency, again, is along the vertical axis. The range of scores along the horizontal axis, this time numerical. And column widths are equal again, so each of these columns are going to be equal in width, and the column height, again, represents the frequency, if you just follow along to the frequency axis. Okay, so what I'd like you to do now is read the case study from page 502 to 503. Just to get back, the column graphs and histograms, there's an example of those on page 502 in your textbook as well. Read through the case study, please, 502 to 503, and then read through example 1 on page 504. And we'll work through a few examples tomorrow in class. I will again repeat this homework for you, but what we're going to be doing in class after we work on the examples from page 504 and onwards, we'll be looking at the questions 1 to 4. Okay, and then there'll be additional work on a worksheet. We'll be doing numbers 1 and 2 there. Okay, but we will work through some examples tomorrow, and please feel free to ask questions tomorrow. This is a good way to, over the evening, the information that I've just told you will simmer and percolate, and then hopefully you'll have some other questions for me so we can clear up any misunderstandings or misconceptions, and then move on to the examples, and then you've got some time to practice in class. Okay, well, thank you for watching, and we'll see you in class.